Hello, ladies and gentlemen. So let's talk about the method of common factoring. Where did I put my pen? There it is. So method common factoring for indeterminate form. Okay, so this will be pretty quick. I just have two examples for you. So evaluate both. So the first one's going to be the limit as x approaches 3, negative x over 3 plus 1 over top of x minus 3. And our second one is going to be the limit as x approaches 5 of 1 over 3 minus 1 over x minus 2 all over 2x squared plus 50. Okay, so those are our two. Looking at them, you can see that they look a little ugly, so I would kind of start making them look prettier by putting brackets around the numerators and the denominators. That's what I would do anyway. And I would notice that they are limits of quotients, which means I'm going to work with them as the quotient of the limits. In other words, I'm going to take the limit of the top and I'm going to divide it by the limit of the bottom. They are polynomial functions, the numerators. All the numerators are polynomial functions. So as x approaches 3 in this one, this is going to go to negative 3 over 3, which is negative 1, plus 1, which is 0 on top, which in of itself is not a bad thing. But couple that with a 3 minus 3 on the bottom, now we're in trouble. We have indeterminate form. And the same thing's going to happen over here. As x approaches 5 here, 5 minus 2 is going to be 3. So it's going to be 1/3 minus 1/3, which is 0. And the bottom is going to be 5. So 5 squared is 25 times 2 is 50. And I've obviously written that down wrong because that is not a problem. This must be a negative here. So fix that. And I'll fix that in my notes. Otherwise, it wouldn't be an issue. The bottom wouldn't be 0 and we'd be good to go. But, hey, I changed it, so now it is 0. Okay, so let's take a look at this. So if I'm going to go after a common denominator... Ooh, how long has that been up there? That's not good. There we go. Sorry about that, people at home. So if I'm going to go after a common denominator on the first one, I'm going to go after a common denominator in the numerator first. So it's going to look like this. I'm going to make it negative x plus 3 all over 3 all over top of x minus 3. And I hope that doesn't hurt anyone's head too much. What I did was I took the negative x over 3 plus 1 and I changed it to negative x over 3 plus 3 over 3. Since they have the same denominator, we can just make it negative x plus 3 all over 3. So I'm never, ever, 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 ever going to show you that again in this course, but I'll show it to you once, and that's what's happening there. So I'm getting a common denominator in the top, and I have the common new denominator in I'm getting a common denominator in the numerator. How's that grab you? A common denominator in the numerator. All right. So then, what does this happen? Just using a little bit more algebra here, I'm going to change this to the numerator divided by or multiplied by the conjugate x minus 3. So what I did was I separated this, so I took the numerator out and I'm multiplying it by the reciprocal of 1 over the denominator. So you'll notice that if I was to multiply this using fractions, it would be top times top, bottom times bottom. So this would now become the limit as x approaches 3 of negative x 3 over top of 3x minus 3. And again, I'm just using some algebraic manipulations here that I hope that you're comfortable with. My experience says that you're not comfortable with it. A lot of you, this is going to bug you. You're going to have to practice it. You'll get it. We haven't been as strict as we probably should have with your algebra if you were going to end up in calculus and vectors. Okay, so in grade 9, 10, and 11, those things. Now looking at this, I'm looking for a 0 term. As x approaches 0, or x approaches 3, this goes to negative 3, this is positive 3, so that's 0. And the bottom is 3 minus 3, so that's 0. But these are not the same. I just can't willy-nilly be canceling them out. You'll notice if I put brackets around it, you can definitely see that they're different. It's the 3 that's negative in this one, and the 3 is positive in this one. So we're going to common factor out a negative 1 in the top. And what that does is it changes the signs on the inside, so it's going to be x minus 3 now, over top of 3, x minus 3. And you now do have equal terms that can be reduced. And they are both 0 terms, which is going to give us an answer of negative 1/3. And that is how you play that game. That's just all she wrote. So, I'll give you a chance to copy that down, and while you're copying it down, the rest of you can sort of look at the other one that I've got happening here. So I've got a numerator, and I've got a denominator, and I'm going to go after a common denominator in the numerator. So the limit I'm going to leave on the outside. I'm going to go after a common denominator in the numerator. So that's going to be x minus 2 times the 1 minus 3 times the 1 all over top of 3 x minus 2. Now again, that shouldn't be too difficult, but you may want to stop and think about that. And look, when I do this, my limit sign ends up in the air somewhere. That always happens. It bugs the heck out of me. So I'm going to bring it back down, because really what this is the limit of this entire thing. So again, what I did was I cross-multiplied here. So x minus 2 got multiplied by 1, the 3 got multiplied by the 1, and then I had the bottoms being multiplied, which is the 3x minus 2, which is going to give me the limit as x approaches 5 of x minus 2 minus 3 over top of 3x minus 2 times 1 over 2x squared minus 50. So again, it's the same little trick that I did here. So I took this part, which was the division, and I made it multiplication by the inverse. So again, what I'm going to be looking at here is just sort of cleaning this up a little bit. Cleaning up the top, I'm getting x minus 5. On the bottom, I've got a 3, an x minus 2, and a 2x squared minus 50. My goodness, kids, do not expand. If you expand here, you're absolutely wasting your life. Expanding's not what you want to do. Okay, you're looking for 0 terms. You're looking for factors. If you expand this, there's no goodbye. You're going to be working on this question forever. You're never going to get to where you want to go. So you should never, ever, ever be looking to expand this. If anything, we're looking to factor this to get more 0 terms. As x approaches 5, this is my 0 term, kids. X minus 5, that's my 0 term on top. So I better be able to find an x minus 5 somewhere in the bottom. I ain't going to pull it out of 3. I ain't going to pull it out of x minus 2. The only place I'm going to be able to pull it out of is there, so I better start thinking about it. So the limit as x approaches 5, therefore, of x minus 5. Again, I said the 3's useless. The x minus 2's useless. Common factor out of 2, I get x squared minus 25. Well, that's good. That's really good. That is a 0 term. The top's a 0 term. The bottom's a 0 term, but they're not the same 0 terms. So that's no good to me. I need the same 0 terms so I can be able to reduce. Well, luckily for me and you, we know a little bit about terms like this. Those are called differences of squares. So that's going to be x minus 5, x plus 5. And did you notice I dropped my 2? So I got to pick it up somewhere. And make that line nice and long so everything goes underneath it. So again, careful, I dropped my 2, but I knew I dropped my 2. So I picked it back up. And now what I'm going to get is this 0 term and this 0 term are going to go bye-bye. And then I'm going to get the limit. I don't want to do the limit. I'm going to evaluate the limit. So look at, this is important. Notice how I've had the limit all the way down the page. The limit has to continue all the way down the page. When I go to put the limit in, pretend with me. I'm going to go and start the limit. I'm going to go and press the limit button. You ready? Ring, ding, ring, ding. I'm starting the limit. X is now approaching 5. X was not approaching 5 before, but X is now approaching 5. It's approaching 5. As it approaches 5, that one's gone. It's been reduced, but I no longer write the limit. I'm going to write 3, 5 minus 2, 5 plus 5, and 2. And I no longer write the limit because I'm evaluating the limit now. Now's when I can stop writing it. And I'm going to get an answer of 1 over 3 times 10 times 2, which is 12, which is 120. And I think that's right. And I'll look to my studio audience and see if anyone yells at me. But I think 3 times 3 is 9. Oh, I'm wrong. Studio audience didn't yell at me. I found it. 3 times 3 is 9. Times 2 is 18. Times 10 is 180. Loser, Mr. White. All right, so it's 180. All right, I'm going to stop the video there, and we will be back with rationalizing.